What's up, everybody? Welcome to Earth Science. Let's look at Google Earth a little bit. Let's get my head out of the way. And see how when we change Earth's surface, we change what happens to the water that inevitably falls out of the sky as rain, right? Water falls, hits the ground. How does that change as humans change the surface of the Earth? Okay. So here's a satellite photo of the area around. This is 481 and this is 31. If you've been to Great Northern Mall, that's it right there. This is from 1994. If you see down here, that's the date. So 1994, when people still went to malls. Look at all the cars. And then you come across 481 right there, and you've got like a Wegmans. I forget what these first couple are. Couple of stores right there, right, with parking lots and so on. All right. Now, 94, I was in high school, so it's not that long ago. Let's look at what has happened since 1994. If I turn off the classical imagery and go to today's imagery, you can see that they've built in quite a bit. So let's consider, again, the whole idea here is back then, what would happen if rain hit these? This is like farmers' fields, open land, right? And yeah, before that, it would have been woods. But with farmers' fields, at least, if water hits the ground, and go back to this permeability, porosity, and capillarity that we did, as water hits the ground, it can infiltrate down in. It can soak into the ground. Versus now that this is like there's a Walmart, a Home Depot, a Target, all kinds of stuff over here. When water hits, it can't soak into any of that stuff. It's called impervious cover. Water can't soak into asphalts or into rooftops of stores or any concrete slabs or anything like that. A few people have come up with some permeable asphalts, which is great. It'll help solve some of these problems, but it's for the time being a little experimental and expensive. So over this much area, look what we got here now with the areas labeled D, C, and E. And you can see another little one right there. Across the street, same deal. This is like Chipotle and Lowe's. Same deal. We have to build these things called retention ponds because if the same amount of water, let's assume that the amount of water climatologically is about the same that falls out of the sky from season to season to season. If that amount of water is hitting the ground and now it can't hit and slowly soak into the ground and slowly work its way down gradient towards whatever river might be near here to take it towards Lake Ontario, it's got to very rapidly go somewhere. So if you don't build these retention ponds, you end up, as soon as you cover this all up, you end up with flooding, very quick and instant flooding. Okay, so there's let's look at one other spot if I can find Central Square quickly. There we go. Maybe some of you guys have been to this one a bit more often. So Central Square, where it meets 81. This is the Walmart that's right there, which I worked on testing some of the concrete. I used to work in like construction testing. I tested some of the concrete out here. So I was at this build from the time that it was basically a cleared site. I wasn't there when they excavated the site, but totally dug all this out. So it was just exposed soil. Graded it to make it flat to build the place, and then as soon as they started construction, I was showing up from time to time. I don't know if historical imagery will go back that far. Let's see. Yeah, to 85, so it might just be, yeah, it's kind of terrible resolution, though. There you go. So 95, again, same deal, farmers' fields. So the reason I bring this up, this is also a bit of a slope, like from right here, and if you go today, you can see, like if you park your car over on the right side of the lot, you can see there's like a steep slope right here. So it was from here to here, a gentle slope. If I can do it on camera, like a nice gentle slope. But you can't build a Walmart on a nice gentle slope. So what they do is they go steep, flat. So what happened was before any of this was, before the site work was done to run water somewhere, we all showed up to do concrete one day, and the whole entire floor slab was under like an inch of water because it rained the night before. And where you used to have fields with a slow natural slope, now you just had impervious cover, steep slopes. exposed soils don't absorb water as well as soils that have any sort of vegetation in them. The roots help loosen it up and allow the water in a little bit more. So it was a flash flood, an instant flood that day. So we all left. We all got sent home. As you drive in now, you see what they built for water retention, and there's going to be most likely storm sewers there. I'm sure we could see them. Can't really see them up here, but they're around to funnel the water all down into this thing. So let's think about two things. Okay, we got flooding's faster because of all this impervious cover. Now, what else is going on here? Every car that's got a little bit of leaking oil, leaking brake fluid, any of that stuff, now that's got like a highway to transport it right into bodies of water as we build this impervious cover. So it's a tough issue. I mean, what do people do? Like we're not gonna knock down every building and revert back to nothing, right? So what are some strategies that we can use to overcome this amount of water? This is my old neighborhood back in 02 to 07. I owned that house right there at Letter I, Tipperary Hill in Syracuse. Now, what they had for years was a combined sewer and runoff drainage system, which meant that everybody that flushes their toilet, that all goes down to sewage treatment plants, as you can imagine. But also, every drop of water that hits the ground and runs into storm sewers, I don't know if we can see any from here, but every drop of water that hits the ground and runs into storm sewers went into the same exact system. And that system then was easily overwhelmed. It's right down here next to the mall. That system could be easily overwhelmed if there was a heavy rainfall because of all the impervious cover that continued to spread out. And they had no choice but to then just open the gates and let it flow into Onondaga Lake. So raw sewage directly into the lake as a result of that. This lake's in enough trouble. Does not need that happening at the same time. So the idea is that we got to fix that. That's no good at all, right? So what they've done is they've built these rain gardens. This is there was one where you could see some of the work they did. There we go. So what they do, they dig out a big pit, they fill it in with sands and gravels, things that can retain water a little bit, and then storm sewers, they separated from the main sewers, and they ran into these. So now every raindrop that hits, it hits this guy's roof, it goes into a gutter, he's got it going into his driveway directly down to the road. It's a lot of rain. I mean, if you get a half an inch of rain, which is a decent storm, but not outrageous, think of that. That's a half an inch over that entire area, times the number of houses that are here. All of that's got to go somewhere. It very quickly turns into an enormous amount of water. So what they did was build these rain gardens and then divert the storm sewer systems across. You can still see in some of these. That's where they dug out right across Avery Ave here and ran pipes to take that water into this rain garden. The idea here is that they build plants that are capable of living in an area where it floods and drains and floods and drains. So this is like a natural area to allow the water to drain and evaporate. If it gets too high, yes, it goes back into another system, but they're meant to be like an intermediate step. You're trying to slow the flow. You're trying to and this is where, when this whole Corona thing happened about this time last year, was when I was teaching this lesson, the flatten the curve idea is mathematically exactly the same. If all of that water all at once goes into the storm sewer system, it's too much. With our healthcare system, if everybody got the COVID very quickly, it would overwhelm the healthcare system. So that's why we had to start saying everybody's got to spread out. We got to slow this thing down. Same philosophy. We have to slow down the water before it makes its way downtown to the sewage treatment plants. So there's rain garden here. There's another one right over. There's two of them in this park, maybe right there. If you ever go to the zoo, if we're ever allowed to again, that's what all of this is rain garden infrastructure. There's some signage around there to explain it. So take a minute before you go into the zoo and check it out. And then there's a couple more right down here at the bottom. This is where you pull in at the bottom of the hill to get up to the zoo. They built a couple more down there. And that slows that flow of water as it comes. All right. So I'm not sure exactly what we're going to do assignment-wise to try to digest some of this. Thanks for watching and keeping up with it. But I'm probably going to have you try to look at a couple of things, including maybe Ellicott City, Maryland. What has happened there is that it's an old city. It's been there for a while and it's flooded, but through the years, the flooding has gotten worse and worse and worse. And a lot of that has to do. It's a cool looking little town. It's in this narrow valley. It's stores and shops and things like that are all pretty neat looking. But what has happened is that upstream, as this area has developed, when it rains, if this was all woods, again, it could slowly go down into that valley. But now that it's stores, parking lots, all that water very quickly goes down into that. And I'll post some videos of some of those floods. They're terrifying, right? It's impressive in a nature way, the amount of water that goes through there, but scary. All right, so we'll check that out. I don't know. I probably there's not going to be a lab. There's probably not going to be a quiz. I might just have a thing or two, and maybe we'll let people explore it as they can and catch up. But thanks for tuning in so far, and consider rainfall and where it has to go in different areas. We usually this time of year too, we walk the whole campus here and think about where water has to go when it hits this whole campus. Again, if this was all still woods, water would infiltrate slowly. But where's it all going to go? There's storm sewers here. And Miss Sheehan's class, maybe some of you guys, I don't know, spray painted on the storm sewers things like, hey, this goes right into the river. It's something to be aware of. If your car is leaking something, water hits it, picks it up, it's going right to the river. So I think we have internal drains on the roof because we've walked around the whole school and I don't see any sewer drop off. So I think they hit the roof, they gather, and they go down through the inside of the school. But there's drains through here. There's a bunch of drains through here, and we've got to avoid that person's property. It all ends up down here, and then again, eventually downriver. Those are our little retention ponds. So yeah, consider rainfall, and if we get a rain, think about what happens to that water. Maybe try to make some observations, walk around a little bit. Check it out. All right. Thanks for tuning in. We will see where we go with this.